So here we are then. This is a bit of algebra, and we're going to start off looking at some equations. There we are, look, equations. Now, for those that are interested, and I know that's all of you, the word algebra actually comes from an Arabic word, al-jaba, meaning the reunion of broken parts. And this page you can see here is a page from a book written by a gentleman called al-Khwarizmi, who was the first, possibly the first exponent of algebra. I don't know what this page says. And to be honest, it could be a page from anywhere. I got it from Wikipedia, so apologies if it's actually a restaurant menu or something. I'm trusting Wikipedia on this one. This isn't al-Khwarizmi. I couldn't find a picture of him, so I'm showing you a picture of the gentleman who cooks my curry in our local Bangladeshi restaurant. He's a very lovely man. I think we'll leave him up there, and we'll just shrink that down and pop that there, and that can be there as a reminder to us of wonderful curry, and possibly a restaurant menu. So this picture, this is what you might be faced with if you continue with your maths career and go on to A-level maths. And it looks pretty horrific, but like anything, you don't learn the horrific stuff first. You build up in steps. And this is a form of equation, needs solving, and we're not going to be doing that one, you'll be relieved to know. So what are we going to do? Well, we're going to do some simple equations, and by simple I mean simple. This is pretty simple, look at this. We've got an equation, 6 minus m equals 5. Reasonably straightforward, you can probably look at that and guess the answer. But what we're going to do is we're going to learn a method to do this, and it's a method that we can apply for all our equations. And really, a method's only really a good method if it always applies. If you have to change a method depending on the circumstances, then I don't think you've got a good method. Anyway, I've said method often enough now, so let's go for it. What we really want is we want to have our letter m on one side of the equal sign and a number on the other side of the equal sign. It doesn't matter which way round those are. The m can come first or it can come second. The equals only really means it's the same as. So at the moment, I've got this little fella here that's messing up my lovely scenario of a letter and a number. So what do I want to do? I want to lose that 6 somehow. And how do we lose the 6? It's a positive 6. There's no sign at the front, so we know that it's positive. Well, we subtract the 6, and we do that from both sides. So if I subtract 6 from both sides, I'm going to be left with negative m, and this is somewhere where people fall down really often, is forgetting the sign here. We've got negative m equals 5. Is it equal to 5? No, because we subtracted 6. So we've got to subtract 6 from both sides. So it's not 5, and 5 minus 6 is minus 1, or negative 1 if you prefer. So now we know that negative m equals negative 1. We want m, really. We don't want negative m. So we have to multiply throughout by negative 1. If you've got a negative here, then this is a stage you're going to have to do. You're going to have to multiply everything by negative 1, and it turns all the negatives into positives and all the positives into negatives. So negative m multiplied by minus 1 is m, and minus 1 multiplied by minus 1 is 1. And so here we are, we have m equals 1. A very long-winded way of going about this original equation here, because we know that 6 minus m, it's got to be 1. 6 minus 1 equals 5. So let's ramp up the difficulty a little bit. Let's have something like this. 5, helps if you turn on the drawing tool. 5 plus 4p equals 13. So it's a little bit more complicated. You're going to have to give some thought to what p equals, but we're going to be using the same method as we used a second ago. Just want to stress at the moment how important this thing is here, the equals sign. we grow up kind of learning that equals means here comes the answer, and it doesn't mean here comes the answer. It really means that everything on this side balances exactly everything on this side. It's like the pivot or the fulcrum on weighing scales, which is why we use the method that I showed before when we subtracted 6 before. We subtracted 6 from both sides, and it has to be both sides, otherwise the two sides won't be equal anymore. You can't take 6 away from here or 5 or anything and it remain equal to this side unless we've done the same here. Okay, so what are we going to do? We're looking for, once again, you can see I found the pointer this time. Okay, brilliant. What I want is I want my letter on one side. At the moment it's 4p, but we'll deal with that in a second. I want my 4p, I want my equal sign, and I want a number. And again, we've got this little fella here who's messing things up. So let's get rid of that 5. And once again, we have to do subtract 5. And we're going to subtract 5 from both sides, which loses our 5. It leaves us with positive 4p. As it's on its own, we don't put a plus inside on the front. Equals, and we're taking 5 away, so 4p equals 8. Now it's looking a lot more straightforward. What do I want? Well, I want just p, I don't want 4p. How do I get p from 4p? Well, we divide by 4. And 4p divided by 4, if we actually had 4p divided by p, everybody would have 1p. Do we write 1p? No, because we're not total novices at this. We know that we don't write a 1 in front of letters in algebra. So we are left with p equals, and 8 divided by 4, well, that's 2, isn't it? So p equals 2. Then what we have to do, really, and this is good practice for you, we go back to the original equation and we substitute our answer, make sure that it works. So we've got 5 plus 4p. What's p? Well, it's 2. So it's 5 plus 4 lots of 2. 4 lots of 2 is 8. 5 plus 8, yes, that does equal 13. Tick. Hurrah. Now we're going to have added complications. Look at this. If we've got 3c plus 7 equals 9. That is a 9. There we go. Subtract, let's say, 5c. Well, now you're looking at this thing, and dearie me, look at that. Now you're looking at this thing and wondering why I can't write. You're looking at this thing, and it's not clear what c is. I would be most impressed if anybody could have a look at this and just say, oh yeah, so it's 1.2 or whatever. No, we have to go through the process again. Our process is going to be just the same. We're going to do the same to both sides. What we're looking for is a number of, it'll be a number of c on this case, 3c, 5c, or however that turns out, and we want a number on the other side. So, what do we do? This is complicated. Well, not really, not if we do this one stage at a time, and we're careful with what we do each time. So I've got letters and numbers here, letters and numbers here. So I'm going to have to get rid of the number from one side, the letters from the other. So let's start with, well, I've got a negative here, and I don't really like negatives. So the first thing I'm going to do is get rid of negative 5c from this side. And we've got to think about how do you get rid of a negative. Well, you add the same amount. So if you had negative 5c and you add 5c, well, they cancel each other out, don't they? So what we're going to do first of all is add 5c to both sides. Okay, so we're going to add 5c to this side here. Well, I can add 5c to this side. I've already got 3c. If I add 5 more c, I'm going to get 8c. And I still have my plus 7. And that equals, well, it equals 9. And that's it, because we added 5c to negative 5c, and that's, for us, very conveniently got rid of the negative 5c. So now this is looking a bit more straightforward, isn't it? 8c plus 7 equals 9. What do we want to lose now? Yep, we want to lose this thing here, the plus 7, because then I'm going to be left with 8c equals a number. So what happens when we subtract 7, is that right? Yes, we want to subtract 7 from both sides. Subtract 7. that leaves me with 8c, and 9 subtract 7, that's 2. Very nearly there now. Just as before, we've got a multiple of c. We had 4p last time. This time we've got 8c. What did we do? We divided. So we're going to be dividing again. Divide my 8c by 8. Both sides. 8c divided by 8 is 1c, which we write as c. And 2 divided by 8, well, let's just write it. 2 divided by 8. Which we can then simplify. And by the way, this thing here is a fraction, and fractions are way more useful when you're doing equations than decimals. And I always encourage my students to think about using fractions far more often than decimals. Anyway, that's a whole other story. So we'll just tidy that up a bit. We know that c equals, or 2 over 8 simplifies to 1/4. And again, what do we do? Well, it's going to be slightly more complicated this time, but we're going to substitute our quarter back up here. There, this is going to be complicated. So what have we got? We've got 3c. Well, let's just think about it. That's 3/4 plus 7 equals 9. Take away 5c, 5/4. 5/4, look at that, there. We've got to think about this. So 7 add 3/4, that's clearly 7 3/4. 5/4, well, that's 1 1/4, isn't it? So we've got 9. There's my topless 9 again. 9 take away 1 1/4. Well, let's think about it. Does 9 take away 1 1/4 equals 7 3/4? 9 take away 1 is 8. 8 take away another quarter is 7 3/4. So we get another tick and a hurrah. And I think for now we'll leave it there.